So what are sig figs? Well, sig figs basically is short for significant figures. In chemistry, you do a lot of measuring in the lab. You're taking mass and volume and all kinds of measurements, temperature, and so the significant figures tell you about the precision of a measurement. And you're thinking, significant figures, what is that? Well, significant figures, or sig figs, are digits in a number that are considered to be significant. And you probably didn't realize that digits in a number could be significant or not significant. You probably just thought of numbers as numbers. But in chemistry, we have something called significant figures. And before I let you know exactly how to determine whether a digit is significant or not, I'm going to give you an example of why they matter. Okay, so then you can kind of understand why some digits are significant and some aren't. So really, why do sig fig matters? Well, really, sig figs tell you how precise a measurement is. And you're thinking, now, what does that mean, precise? Well, let me give you an example. So here you have a scale, okay? And you want to, let's say, weigh this pile of sugar here, okay? And you choose a scale that only gives you a measurement to the 1 gram, okay? Which means it's precise to the 1 gram, okay? So this scale is only precise to the 1 gram. So for this measurement, it only gives you one significant figure. You only have one figure. It's 5 grams. And so it gives you one significant figure. But what if you decide this isn't good enough? Let's say you want a scale with more precision. So you look around the lab and you find this scale. And this scale is actually precise to the 10th of a gram. Okay? And again, you have exactly 5 grams of sugar, okay, but this scale is giving you more precision, okay, which is it's a better scale, and it measures to the 10th of a gram. So this scale is precise to the 10th of a gram. So for this measurement, it gives us 2 significant figures, the 5 and the 0. The 0 we say is significant because it tells me that the 10th place was measured, okay, and it just happened to have a value of 0. Okay, this could be 5.1 or 5.2, but for this case, I've measured it and it actually is exactly 5.0. So what if I decide this precision still isn't good enough for my purposes and I want something even more precise, and I look harder and I find this scale in the laboratory and it measures to the 100th of a gram. So it's even more precise, okay? And so this scale is telling me that this amount of sugar is exactly 5.00 grams, okay? So this scale is precise to the 100th of a gram. For this measurement, it gives us 3 significant figures. And these zeros we say are significant because they tell me that the 100th place was actually measured, and as was the 10th place, and it just happened to have a value of 0. It's exactly 5.00 grams. Now, again, you may look at these and think these are exactly the same number, but I think you can see that they are not exactly the same number, because 5 grams tells me I used a scale that's only precise to the 1 gram. 5.0 grams tells me that I used a scale that was precise to the 10th of a gram, and 5.00 tells me that I used a scale that was precise to the 100th of a gram. So the sig figs in a number really tell us how precise our measurements are. And for chemists, sig figs don't just tell us about the value of a number, but also about the instrument that was used to make that measurement, okay? And so it's important when you're dealing with sig figs to not only know what a significant figure is, but how to follow it through a calculation, because those significant figures really tell you about the instruments that were used to make that measurement. So if you reported, let's say, 5.0 grams, let's say you wrote that down in your lab book, but you only used the scale that measured to the 1's place. So you used that first scale, but you wrote down 5.0. You would actually be misrepresenting the scale you used to make that measurement. it would look like the scale was way more precise than it actually was. So you're actually kind of lying about, if you wrote down 5.0, but you'd use that first scale, you're actually kind of lying about the instrument that you used to make that measurement. If you reported, let's say 5 grams, let's say you, from the scale on the right that measured to the 100th of a gram, you just got lazy. You're like, it's 5.00, 5 grams is the same. I'm just going to write 5 grams. You're actually misrepresenting the scale you used, because if you just write 5 grams, that tells me you used the scale on the left, which is a much less precise scale and probably a cheaper scale than the one on the right. So it would really look like you used a scale that's much less precise than it actually was. So it may seem to you that 5, 5.0, and 5.00 are the same number, but actually they're not. They have the same value, 5, but they're different in their significant figures because they're different in the precision of the instrument that was used to give you that number. So they're different because they represent different levels of precision and so have a different number of sig figs. So chemists, we keep track of sig figs because we don't want to misrepresent the precision of our equipment. So when we take a measurement, we're very careful, even if it falls on a 0, if it was 5.00, we're going to write 5.00 down because that really tells us a lot about the instrument that we used. And so we keep track of those and we make sure we make precise measurements, as precise a measurement as we can, and we make sure that we keep track of our sig figs. So let me give you rules on how to determine what a sig fig is. Now that I've told you really why they matter, it's a little bit easier to understand how to determine if a digit is significant in a number. A digit is significant if it's not a 0. That's easy. So 1 through 9, definitely significant. It's the zeros that are the problem. A digit is significant if it is a 0 between 2 other sig figs. Okay, so 203. 2 and 3 are obviously significant. 0 is also significant here because it's between 2 others. What this 0 is telling me is that I actually measured this, let's say, and the tens place happens to be a 0 value. Okay? A digit is significant if it's a 0 that's at the end of a number and to the right of a decimal place. Example, 1.50. This 0 is telling me I measured to the 100th place. The value happened to be 0, okay? But it was measured, okay? And it is significant. A digit is significant if it's a 0 with a sig fig on the left and a decimal point on the right. For example, the number 10 with a decimal place here or a bar over it, that also is a convention that's used, tells me that I measured the ones place and it just happened to be a 0 value, okay? If that wasn't there, then that 0 here is kind of a wild card. Did my scale really only go down to the tens place, okay? I don't know, okay? So that decimal place tells me that this 0 is significant. Any 0 that's just a placeholder, and this is kind of my rule of thumb, if it disappears with scientific notation, it's not significant. So we'll see some examples of that in a minute. But any 0 that is just holding a place for the other digits in the number is not significant. Okay, so let's do a few. How many significant figures does this have? Well, they're all non-zeros, so there's 3 significant figures. Here, this 0 here is between 2 other non-zero digits, which are significant, and so this is a significant figure, and so this number has 4 sig figs. Now, this one's a little bit tricky. We want to say that this has 4, but it doesn't. These zeros are placeholding for this 1. And that's because these zeros, what if, let's say I used a scale that's really only precise to the thousands, okay? It only does kilograms, let's say, and I want to say it's grams or something. I don't really know about these. Could the scale have rounded up? Did I round up or round down to this number? So really, these zeros are only placeholding for me. And so this number only has 1 significant figure. Now, the minute we add a decimal place or say a bar over this, that immediately changes things because that decimal place is telling me that yes, I measured the ones place here, and it's telling me that it just happened to have a 0 value, and so therefore all 3 of these are significant. Okay, so this has 3 significant figures. Now this is where students really get tripped up. These zeros here in a decimal to the left, okay, especially if there's no digit here. These guys are just placeholders, okay? If I were to put this in scientific notation, move this over and say 1.45 times 10 to the negative third, let's say, these numbers would disappear. And so that's telling me that these are only placeholders, okay? So this number only has 3 significant figures. And now here, this 0 is between 2 other significant figures, so it's significant. This one is between a significant figure and the decimal place, and so it is significant. But what about this one on the end? It is significant because it's telling me that this was measured to the tenths place, and that value happened to be 0. So these zeros are either between sig figs or at the end of a number to the right of a decimal place, and so this number has 5 significant figures. Ooh, what about this one? Well, here's a significant figure here and a significant figure here, so the zeros in between are significant. And these are to the right of a decimal place at the end of a number. They're telling me that this has been measured to the thousandths and then the 10,000ths place, and those values happen to be 0. So those are significant. So this has 6 significant figures. Here's another one. Again, this 0 is between 2 other significant figures, and so that is significant. This has 4 sig figs. Here we have a 0 between 2 other significant figures, so it's significant. And this 0 is to the right of a decimal place at the end of a number, so it is also significant. So this has 6 significant figures. Ooh, this is a big one. Okay, these three zeros here are not significant. If I were to put this number in scientific notation, move this decimal place over and say, I would say 4.50010 times 10 to the negative third, right? These zeros would disappear. So that tells me that they're not significant. They're only placeholding. These 2 zeros are significant because they're in between 2 significant figures, and this 0 is to the right of the decimal place at the end of a number, and so it is also significant. It's telling me that I measured all the way out here, and that value happened to be 0. So this number has 1, 2, 3, 4, 5, 6 significant figures.